Alright guys, welcome to this page of the notes. What I got is one more type of example problem that's going to be in this form where I give you the equation in standard form. Well, we have to do a little bit of rearranging first, but I just take a quick look at it and I notice the x is to the first power. It is the y that is squared. So once again, I have a horizontal parabola. Whether it opens left or right, we'll get to that in a second. So let's go ahead and once again practice completing the square. This is going to be the fourth time we've done it. We'll go through this one pretty quickly here. You should be getting good at these, at least to the point now where you can at least combine some steps and put them together to kind of shorten these up a little bit. The equation I gave you was this: 3x minus y squared is equal to 4y plus 25. All right, I got to get the x by itself. That means moving the y squared to the other side. So 3x is equal to y squared plus 4y plus 25. I need to get the x by itself, so that means dividing by 3. But algebra says whatever you do to one person, if I divide that guy by 3, you have to divide everybody by 3. Divide by 3, divide by 3, divide by 3. X is equal to 1/3 y squared plus 4/3 y plus 25 thirds. Okay, fantastic. Here we go. Remember the way that we complete the square. Oh, actually, I apologize. X equals, it is the y that is squared. We already knew that. It's horizontal, but my a is positive. So once again, we have a parabola that is horizontal opening to the right. Opening to the right. We'll fill that in here in a second. Two things we got to do. First, we have to create a little workshop in order to complete the square. We'll do that by putting parentheses around the y squared and the y. But I also need this to be a leading coefficient of 1, which means I have to pull out a 1/3. We'll do both of those things at the same time. So x is equal, we pull out the 1/3, that leaves with a y squared in there. Then 4/3, but I have to pull out 1/3. Well, it's not that hard. Use a calculator if you need to. 4/3 divided by 1/3 means keep it, change it, flip it. You keep the 4/3, multiply by 3/1, right? 3's cancel, you're just left with a 4. Close the parentheses. That 25 thirds I don't really need, so we just kind of get out of the workshop, get out, just stay out there, just go. Okay, so now that I've got my space to work and a leading coefficient of 1, I will add b squared over 4 inside. Because I add b squared over 4 inside, I subtract b squared over 4 on the outside, but I pulled out a 1/3, so I need to put the 1/3 back. Well, what is my b squared over 4? Well, there's my b. So 4 squared is 16. 16 divided by 4 is 4. So I'm going to add 4 inside, subtract 4 on the outside, but put back the 1/3. We can do all of that in one step. X is equal to 1/3 y squared plus 4y plus 4, right? That's my b squared over 4. Because I added it on the inside, I will subtract it on the outside, but put back the 1/3 that I pulled out. Here we go. X is equal to 1/3. This is a perfect square trinomial. That's why we call it completing the square. So write it as a y plus 2 squared plus 25 thirds minus 4 times 1/3 is just minus 4/3. Those are fractions that already have a common denominator. 25 minus 4 is 21. 21 divided by 3, 7. So I got a plus 7 back there. And there it is. Vertex form A, 1/3. Careful, pay attention to the details. It is a horizontally oriented parabola, which means the K is now inside, the H is on the outside, and it is the K. You got to switch the sign. It's y minus K. If it's y minus K, how did I wind up with a plus sign in here? Well, I wind up with a plus sign if it's minus a minus 2. K has to be a minus 2. So H is 7 and K is a minus 2. Now that I know A, H, and K, guys, it is plug and chug into those formulas on the formula sheet. Let me just quickly give you what I got. Double check to make sure that you're getting the same thing that I get. There's my original problem, and here we go. For the vertex, which is at HK, we would get 7 minus 2. The axis of symmetry, I get y equals minus 2. The focus, I get 31/4. That's a weird number. But anyway, 31/4 is what you would wind up with if you did H plus 1 over 4a, 31/4, and then of course K, which is minus 2. Oh, that's an ugly parenthesis. Hold up. The directrix is going to be x equals H minus 1 over 4a. Again, not a really nice number, but it is what it is. 25/4 is what I get. Check to see if you get the same thing. And then the length of the latus rectum is still the absolute value of 1 over a, but a is 1/3, so keep it, change it, flip it. You wind up with 3. Plus just a positive 3. So the lattice rectum has a length of 3. Anyway, that's what you get by plugging A, H, and K into those formulas on the formula sheet. All right, what we're going to do on the next page of the notes now is kind of switch gears to where what I'm doing is I'll give you the equation of the parabola and ask you to graph them. Right here, I was just asking you for information, like this is a great, you can kind of see how I could do this if you're taking this class with me, multiple choice, right? On a test, in the directions, I would say, use the following equation for a parabola to answer questions 1 through 6, right? I give you it in standard form. You would have to put it in vertex form, and then you could answer question number 1, question number 2, question number 3, question number 4, question number 5, question number 6, right? So if this were multiple choice on a test, you can kind of see how I would set that up. On the next page of the notes, we'll take a look at if it were more kind of like a free response kind of question as far as graphing goes. Really excited to take a look at these with you, so head on over to the next page of the notes, and I'll meet you guys there.